Welcome everybody to our YAKINDU Traceability webinar. My name is Ömer Gürsoy. I am the product manager of this product, YAKINDU Traceability. Okay, before we start, I would like to introduce shortly itemis. Itemis is founded in 2003. We have our headquarters in Lünen, Germany. If you don't know Lünen, it is next to Dortmund. We have several offices in Germany, one in France and one in Switzerland. So our offices in Germany are in Lünen, Bonn, Stuttgart, one in Leipzig, one in Berlin, one in Kiel. We have about 170 employees right now, and we are a strategic member of the Eclipse Foundation. With the next two slides, I would like to give you a short background information why we are a good company to implement such a solution. So, as mentioned before, we are a strategic member of the Eclipse Foundation, and in this situation, we also are implementing many Eclipse technologies and meta tools. Based on these, we are also implementing, mostly for customers, but also for the open source community, development tools, which can be used in three areas mainly. That are the enterprise application development area, the embedded software development area, and the mobile application development area. And based on the development tools, we are also implementing the actual applications, which are also from these three domains. I'm sorry for the switching between the slides. I think there is an auto switch rule activated on this slide. I hope this is not the same for the next ones. Okay, and as you already can think of, we also providing consulting, coaching, services and support in these three areas. Okay, so why we are a good company to implement integration solution like a traceability solution. We have a background in the automotive domain. So we are involved in many standardizations like REC-IF or EAST-ADL or AUTOSAR. And we have a lot companies, here are a few mentioned, which are producers, also suppliers. So we know the challenges and the problems of our clients, and we are extensively involved in the tool development at our customers. So this makes us or brings us in the situation where we have a lot of knowledge how to integrate this different kind of tools and how to tailor the processes on these tools. Okay, we can talk now about traceability. I guess most of you know the background of traceability. We have more and more functional safety challenges, and we have to deal with higher complexity in our systems, and therefore process standards like ISO 26262 or SPICE even mandated. So here on the right side we have a picture of the traceability requirements of automotive SPICE. And what we figured out and what we saw is that we have to deal with individual processes and tool chains even within one company. even within one department. This depends sometimes on the customer project, on the standards that need to be implemented. So, and therefore you also have individual reporting requirements. Okay, yeah, and I think here it's the same. Most of you know the definition of traceability, but what I want to point out is why we're doing traceability actually. Yeah, we're doing it actually to optimize our daily work. We want to make better cost estimations. We want to monitor our development progress better, and this is the most important. We want to accurately implement, verify, and maintain our systems. Okay, so what are the benefits in detail? I listed here some usage scenarios. They are grouped. We have 5 groups of usage scenarios. One is finding origin and rationale of artifacts. These usage scenarios are a result of a big research where more than 40 big industry companies are interviewed, and different kinds of project managers, process engineers are interviewed, and they are asked for what reasons they are requiring traceability. And this is here summarized in these few slides. So the most used usage scenarios are finding an origin and rationale of an artifact. Here are some examples defined, like the development of test cases based on requirements, identifying stakeholders for the ongoing development of requirements, or for understanding behavior and solving complicated problems. I will send you these slides after the webinar, so you can look into the details of these usage scenarios. The next usage scenario would be the impact analysis. So there are also a few examples, like defect location within the source code for failed test cases, understanding of software artifacts, knowledge transfer to the maintenance team. Another one is the coverage analysis. So we would like to track the state of requirements or task implementation in detail, adjusting project and release plan, or test coverage analysis of specification and code. Another important usage scenario would be the navigation between linked artifacts. So if you want to navigate between specification, design, test, and code, and vice versa. Okay, another usage scenario would be the change impact analysis. So actually it's more or less the same like impact analysis, but here we have another trigger as a specific type of impact analysis. So if somewhere a requirement has changed, we need to be prove which other artifacts are impacted by this change, and want to adjust, fix, or maybe just leave the artifacts unchanged. Okay, so here are also a few examples, like change impact analysis to determine artifacts impacted by a feature extension, or discovering regression tests to be executed after a change. Okay, and the last usage scenario would be the pure traceability documentation for certifications purposes, or customer documentation, or for any assessment, stuff like that. So most of the people do traceability, or still but I think this will change in near future, that if we get more and more nice traceability tools. But right now it is like that in the market, that mostly traceability is reduced to just this usage scenario, to the documentation aspect. Okay, now we have talked enough about usage scenarios. Here we have right now a very simple example about artifacts with which we have to deal with. So on the right side we see the mostly known V model, and here we have some artifact types like user requirement, system requirement, design, implementation, and on the right side of the V we have different kind of tests. Okay, and beside the V model artifact types, we have also mostly artifact types which are also existing, like product management artifacts, like a product or a feature, and we also have things like a task, issue, and change request. So let's talk about change management. Okay, so in these artifact types are somehow connected with each other, and these artifact types have their environment where they are managed. So some people even have ALM tools where they manage everything. We have issue management tools, we have requirements management tools, modeling tools, IDEs, and testing tools. And doesn't matter where you look, you always find a heterogeneous landscape of tools. Like even within one company, there are departments they prefer Jira instead of Track or Bugzilla, and always the same story. Okay, this is a more or less complete picture of a real scenario from one of our customers. Is one of the biggest automotive suppliers worldwide, and this is the automotive SPICE conform process where they configured the process. Here we see they have things like samples. Samples are split into features and sub-features, and these sub-features have related some system requirements which have their input from user requirements, so-called input requirements. And then there is also the whole issue management, change management beside that. And these system requirements are then processed into different kinds of models, like AutoSAR model, UML model, MATLAB Simulink models, and then they are further processed in the direction of specification, implementation, and they have all their testing artifacts on their different levels. Okay, this is a picture how it is right now in the market. So there are many people having a big priority on traceability. They think that traceability is great, that traceability is good, that is even necessary. But mostly the engineers which should have the benefits from traceability, we talked about the usage scenarios, mostly don't really get the benefits. They have to implement trace matrices, or they need to update traces in documents, but they really rarely can trigger impact analysis or coverage analysis, or if they can do it, then it is somehow connected with big effort. Okay, and this is what we want to solve with YAKINDU traceability. So when we started developing it, Okay, how you work with YAKINDU traceability? YAKINDU traceability, if you yeah, um, use it, you have actually two phases. One is the setup phase and the other one is the usage phase. In the setup phase, you would start to configure your process by defining artifact types and link types. So which artifact types do I have, like requirement, implementation, and how do I connect them with each other? Then, in the secondary step, we would set up an environment, like where is my project located? Are there other traces that I want to use? You will see YAKINDU traceability can deal with distributed trace information, with distributed trace data, but yeah, we will see that later on. Then you would set up reports, like coverage reports, specific reports that you require, and with the last step you would do a tool qualification. This is especially required if you are implementing safety critical systems. So the standards like ISO 26262 and others, or the DO standards for the for aircrafts and stuff like that, they all require that you do a tool qualification if the tool that you are using could have an impact on safety critical aspects of your product, of your end product. So this means if you are using YAKINDU traceability and you are developing safety critical systems with it, you need to qualify this tool in your environment. And for this reason, for this task, we are providing some qualification kit which you can use to qualify the tool in your environment. Okay, and if you are done with this setup phase, you can start using it while managing, doing analysis and maintain your trace data. Okay, and yeah, I would like to start with the architecture of YAKINDU traceability to talk about, I think, one of the main features of YAKINDU traceability. If you think of YAKINDU traceability, you can imagine it as a cockpit for traceability, as a cockpit to manage trace data and to analyze trace data. So the traceability management and analysis is done on a persistence layer, which is able to aggregate trace data from distributed locations. So what does this mean in detail? So YAKINDU traceability can distribute trace data on several files. So we have an own file data structure. This is based on EMF actually, if you know the Eclipse modeling framework. We can aggregate even the trace data from different files. This helps you in many situations, in many problems that you could have, or many challenges. I would like to give two examples. Let's imagine the constellation between a producer and the suppliers. The producer wants to implement the product, and he works now with several suppliers. And now the producer wants to be able, even 10 years later, let's imagine one of the suppliers doesn't exist on the market anymore. It would be nice for the producer, even 10 years later, to make a traceability analysis on his products. on the components that even implemented by another supplier. So in this case, a producer could say, okay, if you implementing our order, we don't want we not only want artifacts like source code and all those things, we also want a traceability file which we can use later on to make our analysis on our own. Another scenario would be like, let's imagine you are working with several departments. One department is responsible for component X and the other one for component Y or Y. Then you could even split the trace data between these two departments, and as a product manager I would like to aggregate all trace data together while doing coverage analysis or printing out some reports for the customer. And this is especially very good if you're having worldwide distributed departments, like one department is in Japan and another one in the US and stuff like that. Okay, I think it's clear what I mean. So you can distribute your trace data, and you can even distribute it on databases. So if you have relational databases like MySQL, Oracle, or whatever, you can even distribute your trace data in these repositories. So, and both have their advantages and disadvantages. If you are dealing with files, so you could just version your trace data with your other first level artifacts like source code. You could push it in your version control system. Or if you work with database-based systems or database-based persistence, then you everybody sees directly changes, stuff like that. But if you even use the database-based approach, we even support their tagging, branching, so you can even do your baselines in the database on top of your traceability data. And same like in files, if you want to baseline your files, you could do that in your version control system. So besides the persistence of trace information in databases and files, we also support advanced data mapping. And this means if you have already trace information available, it would be good to also reuse this trace information and to provide this persistence layer to make aggregated analysis and management. So we could think of trace repositories like OSLC services or ALM systems like an IBM, CLM or JAS, or like a PTC Integrity or MKS or Polarion ALM or whatever. So we even have some data mapping implementations for ALM systems like PTC Integrity, so that you can connect to your ALM system and that you can provide the trace information to this nice cockpit. So in this time, maybe you will ask yourself, so if I have already an ALM system in use, why I should use YAKINDU Traceability? Even if you have an ALM system in use, you would benefit a lot from YAKINDU Traceability, and you will see that with the ongoing webinar demo. Okay, other kind of data mapping, we could think of model intrinsic relations. If you think of AutoSAR models, there are even relations or UML or SysML, whatever. Let's think of SysML. There you could have even trace links between requirements and any model elements. And this kind of relations you would also like to interpret as a trace link. So in this case, you could provide these relations through our data mapping to YAKINDU traceability. And yeah, you could think of any other kind of relations. Let's imagine an ERP system like an SAP, where you maybe have a hardware order list, hardware order for a hardware requirement, and you would like to be able, even 10 years later, to make an impact analysis to look for which hardware requirement the hardware is ordered from which manufacturer. Okay, we will start shortly with the demo, with the live demo. And before I start with that, I would like to give you a short introduction before, so you know what you can expect to see. Before we start, we will start with the administration part. So we will step into the role of a process engineer, and we will check how to configure. We will see how to configure YAKINDU traceability. After that, we will see how to navigate through tracing chains, and our trace data. Then we will, this is the Explorer, so it's a tree-based view to navigate through our trace data. Then we will see the traceability editor. So this is used for manually created links. We have also interfaces, APIs to programmatically create and manage trace data. And we also have other kind of management components, but we will have just a quick look on the editor which you can use to manually create your trace links. After that, we will see our graphical component, so our graphical navigation component. This is the YAKINDU traceability overview view. This one you can use to make live impact analysis. So you will see later on what I mean with live impact analysis. This is very helpful to quickly get context overview. And then we will see our issue view. The issues view will show you inconsistencies, will show you change impact analysis tasks if you need to review some changes, stuff like that. And then we will have a quick look on the reporting feature. We will see that there is a nice reporting feature with the what you see is what you get report designer. Okay, now we'll switch to the live demo. So YAKINDU traceability as a Eclipse-based tool. It nicely integrates into Eclipse, but it is not only limited to Eclipse. So you can trace to any tools that you want. We are supporting right now more than 100 tools that are available at the market, but if you need any additional tools, it's very easy to extend the tooling. Okay, we will start with the administration part. So we will step into the role of a systems engineer, which would, or a project manager, which would configure the traceability. And he would start with the artifact types definition. Here we see artifact types like user requirement, implementation, feature, validation test, architectural design, specification, system, requirement, detailed design, and so on. So this is a very small demo. In this small demo, you will see all the features. And to make it clear, it is not a real live demo with many artifact types to don't blow up this demo. Okay, let's have a quick look maybe on architectural design as an example. Such an artifact type get a name here, architectural design, and then it can get an optional color. So you can define an optional color which helps you to identify these artifact types in the views that you are using, here in the overview view or here in the Explorer. And the next important attribute is the tool adapter. So each artifact type is bound to a tool adapter. So you need to configure a tool adapter. In this case, we are using the Eclipse UML2 tool adapter. And this means I can trace to any Eclipse UML models. So, but each of these tool adapters, as I mentioned before, here right now I have installed a few tool adapters for this demo. As mentioned, we support more than 100 tools on the market. So in most of the cases, our customers don't need any additional tools and any additional tool adapters. Okay, so each of these tool adapters come with their own configuration. This means they provide here an own configuration. So we mostly use this configuration to clearly specify which artifacts are mentioned by this type, architectural design. So we specify where these architectural design elements that we want to trace to are located. If we would leave out this configuration, I would be able to trace to any Eclipse UML model in my workspace and there to any element within it. But mostly I want to specify that more clearly. In this case, I say, okay, there is an UML model, a resource, which is located in the project the itemis pedelec design and has the name architectural_design.eap. This means there is an enterprise architect model located in my workspace here, and I want to trace to this model. And I want to make it more clear and specify a subset of this model. Sorry. And in this case, I want to say, okay, I don't want to be able to trace to any element within that model. I just want to be able to trace to a component. So I want to be able to trace to model elements that have the meta type UML component. I could, have here nice syntax highlighting at code completion. This means you can use control space to get this list. And I want to be able, in this case, also to trace to UML interfaces. So I can select this one, and now I'm able also to trace to UML components. Okay. I think this is clear what I mean. Here, I just leave it out, this configuration right now. Don't save it. Here are some other examples, like a user requirement. In this case, our user requirement comes from PTC Integrity, or former MKS. Our implementation is in Eclipse C, so Eclipse CBT. Feature is also coming, a feature definition is coming from PTC. Validation test case is also from PTC. Specification is a Microsoft Word document. System requirement is an RecIF file, if you know the requirements interchange format. and the detailed design is a Simulink viewer, so it's a MATLAB Simulink model. We have a specific viewer, but I will show it later on. Okay, so after you defined your artifact types, you would start defining your link types. So you would specify what you can link with what. In this case, we specified that you can link a user requirement with a system requirement, or a system requirement with your architectural design. And if you want to give this relation a more clear meaning, you could use so-called classifications. Maybe you know that from other traceability scenarios, there are classifiers like verifies, refines, or implements, or whatever. So if you need such names for relations, you could define them here in link classifications and specify them here, and then they also are shown here in the views, and make the relation between artifacts more clear. And you can also give the ends, the artifact A and artifact B's roles, like a source, target, or whatever. So as you already see here, we have a very mature meta model. So if you have any requirements on custom artifacts that custom data that you want to be able to store in the trace data, you can do that by defining so-called custom attributes. One of our customers is using these custom attributes for variant management. So yeah, there are many ways to implement variant management, but one of our customers, he is defining here feature expressions, which are evaluated to define if a specific link, if a specific trace link is valid for a specific variant. You can think of any other kind of custom attributes, so you have the possibility to define them here, and then you can also write them down while creating your links. And you have also the possibility to define such custom attributes here on the artifact types. Okay, there are several other configuration aspects, but right now I would like to stop the configuration part right now here and go into the usage. So how we can use the tooling. So we now step out of the role of a process engineer, and we will think of a role of a real user, like a requirements engineer, test engineer, tool developer, or whatever. So we have the YT Explorer on the left side. As I mentioned before, it is a tree-based view. So here you can specify different kinds of groupings. I specified here a group by artifact type. So on the first level, I see the artifact types that are traced or linked. We can start with the user requirement. I open the user requirements and see there is only one user requirement traced. And this user requirement is somehow linked with the limit test, with the system requirement and the feature. And the system requirement is traced to a Word document and the UML component. And then the UML component is linked with the function, C function limit reached, and MATLAB Simulink block. So this is the tree-based view of this trace chain. And on the right side, you have graphical view of the same chain. We have a feature on top. A feature is somehow linked with the user requirement. Here on the logos, you see where they're coming from. So this is managed in PTC. The user requirement is managed in PTC. Limit test is managed in PTC, so in our LLM system. But then this system requirement is in Regifile. So this is just a sample scenario. You can manage your artifacts wherever you want. This is the flexibility of YAKINDU traceability. You can interconnect your artifacts, doesn't matter where they are managed. Okay, and this requirement is linked with the control component and stuff like that. So how you navigate through them? So just a double click on a linked element here or there opens that element in its origin authoring tool. So here I just double clicked on the element and the PTC Integrity web user interface opened, and the user requirement that was linked is directly opened. So here you see one of the biggest advantages of YAKINDU traceability. You directly navigate into the authoring tools, and this is a big benefit for your engineers. Yeah, I see this user requirement. I opened it, is here in PTC Integrity. Okay, then there is a requirement in a Recif document. Then there is a UML model element. It's open the UML model, and the element that was linked is pre-selected. Same for Word documents. I double click on the Word document, and the element which was linked, in this case this text mark, is pre-selected. Yeah? And this works also in the other way around. So if I have opened a Word document, I just click on text mark, I see there is no context for it. But if I click, just place my cursor in this text marker R0004, I see directly the context of this element. So this is what I call live impact analysis. Yeah? Engineer doesn't have to open a document or an ALM system to see with which other artifacts this element is linked. He just places his cursor on it and directly gets an context overview. And we can look further. This is the UML component. Then there is a limit reached C function. You already see again the C function is opened, the C file is opened, and the function that was linked before is pre-selected. Yeah, you can think of a situation, you get the bug report 10 years after development. You open your code, your implementation, place your cursor into that place that has a bug, yeah, and you directly get this impact analysis. And the same here is a link to a Power Window Control System block. As I mentioned before, we have a product. This is called the MATLAB Simulink Viewer, or actually we need to change the name because of some low issues. But with this tool, you can navigate nicely to and very fast through MATLAB Simulink models. And with the same here, I place my cursor or select an element, a block which is not linked, I have no context, select a block which has a context, and I got directly here my impact analysis. Okay, I have a very nice quick problem. I need to restart my development environment because my internet connection broke, and I'm connected to an ALM system which is located on another location at itemis. So therefore I needed to restart quickly. I'm sorry for that. Okay, so as you see before, these are the navigation possibilities. Okay, maybe before we go into the link creation part, I would like to show you some customization features. This is a very small demo, but you can think of projects where you have more than, let's say, 100,000 trace links. Then you need several possibilities to customize these views, otherwise you blow up these views and it is very hard to navigate through them. So for those reasons we have many filter features or grouping features or sorting features. One of those is here the quick filter view, where you could say, okay, I'm a requirements engineer and I just want to see the links between user requirements and the system requirements. Yeah, and then I would just have this kind of links. I'm sorry. Okay. Or we have filter configurator. This means you could implement filters. Let's say we just want to see the links between system requirements and the architectural design. We could click together such a filter rule where we say, okay, we want only to see the links where artifact A type is of type system requirement and the artifact type B is of type architectural design. So you could even interchange or provide these filters to your colleagues or import filters from your colleagues with this export and import features. And if you configure such a filter, you could activate it here and you would just see only those links that conforms to this filter that you specified. Okay, now I think this is enough for navigation aspects. Let's have a quick look how we can create trace links. And this is done with the YT editor. In the YT editor you have actually 3 parts. This is the recently selected artifacts part. We will see later what you can use it for. And the artifact A and the artifact B sections. So what I'm doing is actually, if I create a link, I link an artifact A with an artifact B. So you can select an artifact which you want to link by searching for it, or just by selecting it. So let's see how we can search for it. I click on the search button, then I specify the type which I want to link. So I want to link, in this case, maybe a user requirement. And then I will get all the possible user requirements. This means, because we configured YAKINDU traceability so detailed that it knows where to find the elements, he can show you here all possible elements. In this case, maybe we link the same requirement with another system requirement to see it later on here in this view. So 22380, 22380. Okay, I want to link this requirement with a, let's say, system requirement, or maybe nicer function would be to link it with Word, just to show it how it works with Eclipse external tools. I would like to link this system requirement, so requirement 2, with a Word artifact. So I open my specification. Oops, this is the word can't be opened with Eclipse, so we need to open with the system editor, which is Word. So, okay, if I select here now the 2, I can select it here and say just save. And now, if I have a look on it, the system requirement 2 is now linked with the R002 and R004 text markers in Word. Okay, this is how you can use the link editor. I used mouse clicks, so you also have keyboard shortcuts that you even can change to work more quicker. Okay, another thing what we are having is this issue view. With the issue view, you can check for model inconsistencies, for trace data inconsistencies, or let's say change impact analysis. So if someone changed a requirement, he could, and other colleagues could just trigger a so-called validation, in this case a suspicious artifacts validation. If I trigger it, you see there is something happening in the background. Now we found out that there are 4 warnings. This means there are now some links suspicious. You see there are very small warning symbols. This is a problem with my 4K display and Java. Our symbols are actually a little bit bigger, but on this display they are shown very small. But our usability engineers are already working on it, so these things will be much better with the next release, even if you have a 4K display. However, now we see here some suspicious links. If we select them here, and this is also not very clear, this line here get a slight border. So this means if I select here a suspicious link, I can see that there is something changed. And here it says that the requirement in the ALM system, the pedal assistance turn off and so on, has changed. So I can navigate to the ALM system, check quickly what is the change, and then I can check my other artifacts like my requirements document, my Regex document, or my Word document, and quickly check if the change in the ALM system of the user requirement has also some impact of to my specification. I could change my specification. If I am done with that, I can just quickly fix that issue and would say, okay, update version. So, and then that is fine right now. So, and this I would do with all these suspicious links, and I could say, I could review change impacts. Okay, now I showed you some views and navigation possibilities, stuff like that. And let's have a quick look on the reporting aspect. Let's make a coverage report. For this purpose, we have this report wizard. If you open the report wizard, you can use a default report, but the default report actually just have statistics, which artifacts are traced mostly, or which resources are traced mostly, and stuff like that. But if you need things like a coverage report or trace matrices or whatever, you need to specify your own templates. In this case, I prepared a very simple and small coverage report. You need to define the output file name and the directory where it should be written. And then you can also specify the output format like PDF, HTML, doc for Word documents, and Excel files. So just to be clear, here is nothing generated right now, otherwise I would delete it. So now I click on finish, and then we see that the report is rendered. Let's open the PDF report. In this case is, as I mentioned before, a very simple coverage report which shows which user requirements have no system requirements linked. So we see before there are 11 requirements in our PDC system in a specific project. And yeah, there are 10 of 11 user requirements not linked with system requirements, and those are listed here. Okay, and as you already, I guess, think of, there is also a nice what you see is what you get designer, and this is based on the Eclipse BIRD technology. BIRD stands for Business Intelligence and Reporting Tools. It's a very nice reporting tool, comes with its own perspective, and it is very comparable with other commercial reporting tools like Crystal Reports or whatever. So it is very nice. You could drop report items like lists, charts, tables, and stuff like that on your report templates. And you can bind these tables or whatever, your items, with so-called data sets. And these data sets are like tables where you can also join or do all your calculations that you need. In this case, I show the user requirements with our systems requirements. This means I fetched all user requirements, so we are providing some drivers for Eclipse BIRD so that you can easily fetch all the necessary data. In this case, I fetched for all candidates of type user requirement. Then there is a table user requirements linked with system requirements. So I queried for links and defined the filter where I said type A is of type user requirement and type B is of type system requirement. And then I specified a joint data set where I made a left outer join, and I bound this elements, this table to this table. Okay, this is how you can specify your templates. It is very easy, straightforward. Trace matrix you can specify within minutes. Okay, now I showed you quickly the most relevant features of YAKINDU Traceability. There are many other aspects. Just to mention one more is how you can specify the systems that you want to also fetch trace links from. As we see here, there is a link between a feature and the user requirement and the limit test. And all these elements are managed in PDC. And here on this lock symbol, you see that these links are not managed with YAKINDU Traceability. They are managed within the ALM system. This means if we have a quick look on the user requirement, then we see in the relations part that is connected to a feature 22388. This is this one, feature control 22388. And it is validated by a validation test case with the ID 22393. This is this one. So how we are reading this trace links? This is the before mentioned data mapping feature. So if you go back in the configuration, you can see that we specify data storages. As mentioned before, we are able to aggregate trace data from several locations. You can specify them here. So our main location in this case is our file. And then we have additionally a data storage called PTC1, which is of type PTC, where we specify where is the PTC server, then the port and stuff like that, and also the projects where we want, which are interesting for us. Here also you have syntax highlighting and code completion. If you press Control Space, you would get the list of all the projects that are available on the PTC server, which are accessible with your user credentials. Okay, I think this is enough for the live demo. I would like to switch back to the slides. I would like to sum up the main features of YAKINDU Traceability. So what is special on YAKINDU Traceability? So one point is the easy process tailoring. As you already saw, it is very easy to set up your process, and this is the feedback of our customers, of the process engineers. They say, wow, I was able within 1.5 days to set up my process and to configure all the tools that need to be connected. It's amazing. So if you even need to modify your process within the development, you are able to do that very quickly, very easy. Okay, another aspect is the extendable tool support. So as I mentioned before, we already support more than 100 tools, but even if you need now a new additional tool, then you can implement your tool adapter with very low effort, or you can ask us to implement it as a consulting work. However, we specified very nice interfaces so you can implement such tool adapters. Very easy one, maybe you implement in a half day, 1 day, or if it's about integrating to ALM system, like a complex ALM system that we don't support right now, then you could think of maybe 20 days implementation work. However, so the extendable tool support is a unique feature, I guess, I think, for YAKINDU Traceability. Another unique feature is the live impact analysis. So you just place your cursor in the C function and you get the direct context overview. And the authoring tool navigation is also very unique. So you can directly step into that tools where you manage your artifacts. This is a big optimization of your daily work. Then the non-invasive trace data management, that gives you a big flexibility. So this means if you need to link a source code with a requirement in an ALM system, you don't need to place any hooks somewhere. We separately persist your trace data. This is gives you a big flexibility. And another aspect is the support for the distributed trace data. So if you have your trace data available in an ALM system and somewhere else, or maybe in different ALM systems, or maybe each of your department located in different places on the world have their own ALM systems in use, then you could even provide interconnection connection between these distributed locations, and this helps you in many challenging situations. Okay, another aspect is the advanced data consistency. We didn't talk about that actually, but I want to mention it here right now, is if you have non-invasive trace data, you can think of that your trace data run out of consistency. So someone changed somewhere an artifact or deleted it or whatever, that would mean you would have inconsistent data, and then any analysis would be nonsense. So for this aspect, to keep your data consistent, we have two features. One is the modification tracking aspect. That means if someone is changing a function or moving a function or whatever, We track these kind of changes if we are able to do that. So the change tracker must be activated and stuff like that. So then the changes are tracked, and the impact on the trace data is automatically updated if possible. Otherwise, the engineer at least gets a hint that he is changing something that has an impact on the trace data, and he needs to fix it. But nevertheless, it still can happen that your trace data get inconsistent. For this purpose, we have another validation. This is the model consistency validation, which checks if the linked artifacts are still available. We can do that because we know the possible candidates, the possible elements that can be linked. So it is just a check if those elements that are linked are still available. Okay, so what we also having in place is a flexible versioning. So you can version your trace data with files in version control systems or in database systems. So it doesn't matter how you desire it, you can do it. And we provide standardized interfaces. This means you have an interface for BERT, so you can nicely connect to the data through the reporting tool. We are also having in place an API if you want to programmatically connect to our tooling, or we also have TCP-based protocol if you want to connect to network to our system. And in the future version, we also are implementing the OSLC standard. So this means all the trace data that is available in YAKINDU Traceability, and this means also the aggregated trace data, would be available through OSLC. This means even if you have a system in use that doesn't support OSLC and you want to use OSLC, then you could do it through the bridge of YAKINDU Traceability. And we also will support OSLC as a consumer, so that you can link to any elements that are hosted on OSLC based systems like IBM Jazz or whatever. Okay, maybe 2 slides how YAKINDU Traceability is implemented. So we started implementing YAKINDU Traceability in a research project 5 years ago. This is the research project Wörde. And there we worked together with many big industry partners, and showed them the tooling, they used them. We had a few turnaround cycles, and then we used it in internal projects. So we using even YAKINDU Traceability within YAKINDU Traceability to make our own traceability with YAKINDU Traceability for assessment purposes, for certification purposes, and then we introduced it in some projects at our customers. And what we are doing there, we always having look on the usability. So we have own usability engineers, dedicated usability engineers that are going to our customers or even talk with possible customers to collect all the information, all the requirements that are existing for such a solution, and we always implement them in our solution. And this is a process that we live ongoing. So what I want to point out as the last sentence is, if you are using YAKINDU Traceability, the engineers carry out traceability not because of audit purposes or standards conformity or whatever. they really do it because of the benefits of traceability. All right, thank you so far. And right now I will stop the recording